Okay, welcome back. This is lesson 14, part 2. So as you can see off to the side here, the first 3 slides of our PowerPoint are what we've gone over so far. We mainly focused on learning some symbols, looking at number lines, and talking about interval notation. So all of that will still come into play when we're solving linear inequalities. So what is a linear inequality? Well, linear just refers to the fact that the exponents in these problems, basically you can't see them. The exponents are 1, so there's no exponents. Linear has the word line in it, but basically all you need to know is these problems, just like the equations that we've solved, just have one variable and the variables do not have exponents. So that's what linear refers to. We will be solving linear inequalities. Those are similar to equations, but instead of equal signs, now we'll have less than or greater than signs. So here's what we're going to do. We will solve each inequality, and that will be similar to solving equations. So sometimes we'll use the distributive property, we'll combine like terms, we'll isolate the variable, maybe we'll add or subtract on both sides, multiply or divide on both sides, all that stuff we've been working on, particularly in lessons 10 and 11, a few lessons ago. Then after we're done solving, we have a couple more things to do. We will also write the solution in interval notation. That's what we worked on in part 1 of this lesson, with square brackets and parentheses and infinity, etc. And then we will also graph our solution on a number line. So with equations, when we got an answer, like for example, x equals 2, we didn't graph it on a number line because it would have just been a dot on a number line, which isn't very interesting. The answer would be x equals 2, and that's it. Now, the answer to an inequality, it's a whole set of numbers that goes on forever towards infinity or towards negative infinity. So we visually illustrate that by drawing arrows on number lines. So that's kind of an added part of these problems. Okay, let me take us to a full slideshow here so we can have a little more space on the screen. And then we'll take a look at solving number 1 here. Okay, so number 1, 6y minus 8y is greater than or equal to 14. So we're going to treat this like it's an equation. We're going to solve and get the variable by itself. So let's notice where the variables are. It looks like we have y as our variable. Both of the terms with y are together on one side of the inequality. So let's combine them together. So let's start by doing 6y minus 8y. We're putting them together. 6 minus 8 is negative 2. So we'll combine those terms together into negative 2y. So let's rewrite the problem. Negative 2y is greater than or equal to 14. Okay, so one more step to get the y by itself. What we need to do next is divide both sides by negative 2. Negative 2 divided by negative 2 cancels out, and that's just y. 14 divided by negative 2 is negative 7. And now there's an important extra little detail to notice. And there's a little box off in the corner to let us know what we need to do here. So here's what it says. Flip the inequality sign if you multiply or divide by a negative. So a little side note, let's just take a look over here. So here's a quick example. Negative 4x is greater than 8. If we divide both sides by negative 4, what we get is instead of x being greater than our answer, now our greater than symbol actually flips. It switches directions and becomes a less than symbol. So let me restate our example and we'll get to the answer. Negative 4x is greater than 8. If you divide both sides by negative 4, our answer becomes x is less than negative 2. So again, if you are multiplying or dividing by a negative, that's when you will flip your inequality sign. So here's a quick little example of why we do this, or an example of why this might make sense. So here's a quick example with some numbers. So what if I write 2 is less than 3? That's true. Okay, what if I now divide them both by -1? -2 is not less than -3. See how this statement needs to change? 2 is less than 3, but -2 is actually greater than -3. It all comes down to the number line, and kind of how the positive side is sort of a mirror image of the negative side. Here, so I'm just kind of sketching out a number line. In this little example, 2 is less than 3 because 2 is to the left of 3 in a number line, but then -2 is actually greater than -3 because if you look at the number line, -2 is actually further to the right than -3. So that's just an example with numbers, you know, noticing how positives compare to each other. It's sort of the opposite from how negatives compare to each other. Okay, that may or may not have helped. But what you need to know is anytime we multiply or divide both sides of an inequality by a negative, that's when you will need to flip the direction of your inequality. So that brings us back to the problem we were solving. Okay, so let's recap. Here was number 1. 6y minus 8y is greater than or equal to 14. We combined like terms and got -2y is greater than or equal to 14. Then we were dividing both sides by -2. Because we're dividing by a negative, we will take our inequality sign and flip it. So instead of being greater than or equal to, now it's less than or equal to. So our answer is y is less than or equal to, y is less than or equal to -7. Okay, so we solved the inequality. Now, what is left to do? We have to also write the solution in interval notation, and we have to graph it on a number line. On the homework questions, you will be asked for interval notation first, and then you'll get to select a number line. I encourage you to sketch out your number line first because it's very visual and you'll be able to see kind of which direction your arrow is going. So that's what I'm going to do here. I've drawn a number line. All I've put on here is just 0. 1, 2, 3, 4, 5, 6, 7. I've just counted over to -7. I can keep going if I want to. What we need to know is, where is this arrow going, and are we going to use square brackets or parentheses? So let's decide. Y is less than or equal to -7. So less than means we're going to the left. Let's see. 1, 2, 3, 4. Here we go. All right, so we're going to the left of -7. So I'm drawing my arrow towards the left, which means it's actually going towards -infinity. And because of the equal sign underneath my inequality, it's not just less than -7, it's less than or equal to -7. That's when I will also choose to write a square bracket as part of my arrow. So I have a square bracket facing to the left, then my arrow is pointing to the left towards -infinity. So that's what my number line would look like. Now my interval notation would look like this. Notation, there we go. All right, so it would start with parentheses, -infinity, comma, -7. And based on my number line here and based on this equal sign under my inequality, I need a square bracket around the -7. So parentheses, -infinity, comma, -7, close bracket. So one more time, parentheses, -infinity, comma, -7, square bracket. Sometimes I'll say closed to refer to the square brackets or open to refer to the parentheses. Okay, so let's just kind of run through our list. We solved the inequality, we wrote it in interval notation, and we also graphed it on a number line. Okay, good. So that's number 1. And let's take a look at number 2. Okay, so number 2 involves some fractions. So we will get some practice clearing fractions. All right, 3x minus 3/8 is less than or equal to 1/8 plus 2x. All right, so there's multiple ways to solve this. The way I'm going to start is by clearing the fractions. So here's what that means. I'm going to find the common denominator of my fractions, which Both fractions have the same denominator of 8. I'm going to multiply both sides of my equation by 8. So what I'm doing is essentially distributing the 8 throughout the whole problem. And so you can see I've written each term in parentheses and just written a little 8 next to it. Because the LCD is 8, by doing this, we will be canceling out the fractions or clearing the fractions. So let's carefully multiply each term by 8. And we should expect that the next thing that we write will no longer have any fractions. Okay, here we go. So the first one, 8 times 3x, that is now 24x, minus, here's the next one, 8 times 3/8. Okay, we get to cancel out the 8's here, because 8 divided by 8 is 1. So 8 times 3/8, that's just 3. Okay, again, the 8 divided by 8 is 1, so I guess in a way it's 1 times 3. Either way, we get to just write 3. I'm bringing down the inequality, less than or equal to. Now we're on the other side. 8 times 1/8, we cancel out the 8's and we just get 1, because 8 times 1/8 is 1. Plus 8 times 2x is 16x. Okay, this is something we've done solving equations before, and now we're doing it solving inequalities. We just cleared the fractions. Now let's work on getting all the variables on one side of the inequality. I strongly encourage you to get all the variables on the left side of the inequality. Okay, if you leave them on the right side, it's a little more confusing, especially now that we're dealing with inequalities where the order will matter, the direction of the sign will matter. It wasn't really a big deal with equal signs, but with inequality signs, it will cause some issues. So let's get all the x's on the left side. So here we are, 24x minus 3 is less than or equal to 1 plus 16x. What I'm choosing to do is subtract 16x on both sides. So the 16x minus 16x cancels out. On the left side, now we have 24x minus 16x. So we have 8x minus 3 is less than or equal to 1. Now we get to add 3 on both sides. So we've isolated, we haven't quite isolated. We've gotten all the x's on the left side. And now we're working on getting all the numbers on the right side. So I've added 3 to both sides. Minus 3 plus 3 cancels out. 8x is less than or equal to, and then on the right side we have 1 plus 3 is 4. Okay, so 8x is less than or equal to 4. The last step is to divide both sides by 8. Now be careful. You might think that the answer is 2, but it's not. 4 divided by 8, this is a fraction. So 4/8 is a fraction that we can now reduce. We can reduce by dividing the top and the bottom by 4. So we're left with x is less than or equal to 1 over 2, or x is less than or equal to 1/2. Okay, so I said it before, there's more than one way to solve. So if you did not clear the fractions first, maybe you added 3/8 to both sides or you did something else, that's fine. The answer would still end up being the same. X is less than or equal to 1 over 2, or x is less than or equal to 1/2. So now let's sketch out our answer on a number line, and we'll write the answer in interval notation. So this is actually similar to our last problem, because the last one also ended up being a less than or equal to, I believe. So on my number line, I'm just labeling 0, I'm leaving some space in between, then I'm labeling 1. 1/2 would be in between 0 and 1. So this is true anytime you get a fraction, as long as it's not an improper fraction, like 2/3 or 1/2. Oops, I wrote it wrong, sorry. What I was trying to say is anytime you have a proper or regular fraction, you'll be somewhere in between 0 and 1. If it's negative, it'll be between 0 and -1. All right, so x is less than or equal to 1/2. I've labeled 1/2, that's in between 0 and 1. Less than means I'm going to the left, so my arrow will point to the left. Equal to means I get to use a square bracket around the 1/2. So my arrow is pointing to the left in that negative direction toward -infinity. I have a square bracket around the 1/2. That's my number line. Now my interval notation will look like this. Parentheses, -infinity, comma, 1/2, and then square bracket. for the final answer. So that's what we mean by interval notation. So we've solved for x, we got the x by itself. It kind of felt like we were solving an equation. Then we graphed the answer on a number line, and then we wrote our answer in interval notation, parentheses, negative infinity, comma, 1/2, and then square bracket. All right, so in the PowerPoint, I have a blank slide after this because normally when I would print this out, we would really take up a lot of space with this problem. So there is a blank slide next, and then we'll skip right past it onto number 3. Okay, so number 3 also involves fractions. This one's a little bit different because I'm not going to clear the fractions right away for this one because the fractions are each outside of parentheses. So when that is your original problem, when you have fractions outside of parentheses, I would recommend that you distribute them first. What you'll find is a lot of times this is enough to clear the fractions anyway. But if they don't clear, then at least you're getting rid of parentheses and you can always clear the fractions in the next step. Okay, so here's the problem. It's 1/3, parentheses, 9y plus 3, close parentheses, minus 14 is less than negative 1/2, parentheses, 8y minus 2, close parentheses. So I've started to draw some arrows showing that I'm going to distribute. So 1/3 times 9y. Okay, 1/3 times 9 is really the same thing as 1/3 times 9 over 1. The 9 and the 3 can be reduced by dividing by 3. We essentially get 3y for our first term because 1/3 times 9 is 3. Plus, next we distribute the 1/3 times 3, which is really 1/3 times 3 over 1. The 3's cancel out and we just get 1. So 3y plus 1 is where we are so far. Then the parentheses were closed. So the minus 14, just bring that down. Don't distribute to that because it was not in parentheses. So just copy it down and then your less than sign. Then on the other side, we're also going to distribute. This time we're distributing a negative 1/2. So be careful distributing a negative. Your signs are about to change. Negative 1/2 times 8y. We need to figure out negative 1/2 times 8 over 1, reduced by 2. So that becomes negative 1 over 1 times 4 over 1, which is just negative 4. So I'm going to write negative 4y. And then we'll move on to the next term, negative 1/2 times negative 2. Putting it over 1. Negative times negative, this is now positive. So I'll be writing a plus sign. And then the 2's cancel out. This is just plus 1. So here's where we are. 3y plus 1 minus 14 is less than negative 4y plus 1. Okay, I'm looking at my notes answer key that you may or may not be looking at. If you're not, that's fine. You're getting it here anyway. Looks like the next step I had done was adding 4y to both sides. However, I'm going to go a slightly different direction right now. I think we should combine like terms next. Now, the reality is you can do either of those things and we will end up at the same place at the end. So I'm going to combine like terms. Over here on the left side, the plus 1 minus 14. Let's combine that. Positive 1 minus 14 is minus 13 or negative 13. So I'm going to rewrite 3y minus 13 is less than negative 4y plus 1. Okay, now that I'm done combining like terms, now let's work on getting all the variables to the left side. So I have this negative 4y on the right side. Let's cancel that out. So I'm going to add 4y to both sides. Notice how I'm writing it right below the y terms. So negative 4y plus 4y cancels out. On the left side, 3y plus 4y is 7y. So 7y minus 13 is less than, instead of writing plus 1, I'll just write 1. Okay, I'm going to move on to the next slide, except I don't have another slide. Okay, I'll just move to a blank white space to keep going. So here's where we are, and we'll pick right up in just a second. 7y minus 13 is less than 1. The next thing we'll be doing is adding 13 to both sides. So 7y minus 13 less than 1. That's where we left off. Okay, let's add 13 to both sides. Plus 13, plus 13. Okay, so now 7y is less than 1 plus 13 is 14. So 7y is less than 14. Now there's one more step, which is to divide both sides by 7. Okay. Usually in class, this is where I get a question about, okay, do I have to flip the sign because we're dividing? No. Only flip the direction of your inequality when you're dividing by a negative. We are not dividing by a negative, we're dividing by a positive 7. So don't flip anything. Sometimes teachers get so caught up in showing you when to flip that we show you so many of those that then you think you always have to do it. So only flip the inequality when you're dividing by a negative or multiplying by a negative. Here we're dividing by a positive 7. So nothing flips, just keep the direction as it is. Cancel out the 7s. Y is still less than, and now 14 divided by 7 is 2. So y is less than 2. Okay, that's our solution. Now let's draw it on a number line. All right, here's 0, 1, 2, 3, -1, -2, etc. So I'm just sketching out a little number line, finding 2 on the number line. I'm not including the 2. So that means I will use parentheses, but which way should my parentheses face? Let's see, this is less than. So I'm going to be going to the left. I've seen a few of these today. Going to the left. So that tells me my parentheses will face the left. It's kind of like they're opening towards the left. Okay, so I have an arrow going to the left. There's parentheses around where the 2 is. And remember, if we're going to the left, that means we're going toward negative infinity. So my final answer in interval notation will look like this. Parentheses, negative infinity, comma, 2, close parentheses. That's my interval notation. So we solved for y, we graphed our answer on a number line, and then we wrote our answer in interval notation. Okay, so I only had 3 solving inequalities examples in the notes. As always, you could probably use more. So this is the time where I'm going to do a quick little pause, and then we'll take a look at some problems in the homework in MyLabs Plus and see if we can practice some of these skills and maybe see if there's anything we may have missed and wasn't quite touched on in these first 3 examples. All right. Okay, so here we are in homework 14 on inequalities. This is question 1, and it's a bit different from what we were just doing. It's sort of a yes or no question, and it's a series of yes or no questions. So it says, determine whether the given numbers are solutions of the inequality. So the inequality is x minus 2 is greater than or equal to 9. And then it gives a list of numbers, -6, 3, 4, 13. And over here, we're being asked about the first one, is -6 a solution? So here's what we're meant to do. We're meant to plug in -6 for x. So if I rewrite my inequality, it's x minus 2 is greater than or equal to 9. If I replace x with -6, let's see what happens. -6 minus 2 is greater than or equal to 9. Then if I simplify, -6 minus 2 is -8 is greater than or equal to 9. Is that true? No, a negative is not going to be greater than a positive. So no, -6 is not a solution. So I'll choose no for that. Okay, now it's moving on to the next one. Is 3 a solution? Okay, same thing. So go ahead and plug in 3 for x this time. Oops. Okay, is 3 a solution? So this time I'll replace x with 3. 3 minus 2 is greater than or equal to 9. 3 minus 2 is 1. 1 is greater than or equal to 9. No, still not true. So no, I get to choose no for that one as well. All right, we keep going. Let's plug in 4 this time. Is 4 a solution? X minus 2 greater than or equal to 9. This time I'm replacing x with 4. 4 minus 2 greater than or equal to 9. 4 minus 2 is 2. No, that's still not greater than or equal to 9. Is any of these going to work? We'll find out. So no for that one. Let's try the last one, which is 13. Is 13 a solution? X minus 2, greater than or equal to 9. Okay, so replacing x with 13. 13 minus 2, greater than or equal to 9. 13 minus 2 is 11. Yes, 11 is greater than or equal to 9. It's not equal to 9, but it is greater than 9. So this one, we would say yes. Okay, yes. So that's the idea for number 1. I believe number 2 will be similar. I'll show you a slightly different way you can go about this. If you'd rather not plug in every time in quite the same way, you can solve first if you want to. So for number 2, this is a longer inequality. We can solve it first, and that might make our work easier. So here's the inequality. Y minus 10 is greater than 2y minus 4. Let's solve this one. So let's get all the y's on the left side. So I'm going to subtract 2y on both sides. 1y minus 2y is negative 1y. So I have negative 1y minus 10 is greater than negative 4. Let's keep solving for y. I'll add 10 to both sides. So negative 1y is greater than 6. And then a little bit of a tricky part here. Divide both sides by negative 1. Y is now less than negative 6. Remember, because when you divide by a negative, you flip the sign. So by doing all of that work now, I've made it easier to plug in, I think, because now all I need to do is plug into this inequality. Y is less than negative 6. So now I can run through my different numbers. So I'm looking at 4 different numbers here. The first one is 4, actually. Is 4 a solution? Well, let's plug it in. 4 is less than negative 6. No, that's not true. So we'll choose no for that one. See how I'm plugging it into my answer rather than the original problem? I find this a little easier. All right, next one. Is negative 19 a solution? Let's plug into the answer. Negative 19 is less than negative 6. Yes, negative 19 is less than negative 6. It's sort of further to the left on that number line. It's more negative. Is negative 17 a solution? Yes for this one. Negative 17 is less than negative 6, so yes. Okay, last one. Is negative 2 a solution? Okay, is negative 2 a solution? I'll plug in negative 2 less than negative 6. No, so be careful. Negatives get us all mixed up, right? So negative 2 is further, let's see, 1, 2, 3, 4, 5, 6. Negative 2 is further to the right. Negative 6 is further to the left. So no, negative 2 isn't less than negative 6. It's actually the other way around. So this is another no answer. Okay, so you could have done it a different way. I think if we view the example for this one, they're going to show plugging into the original equation every time, which is fine. But I kind of like solving it first. Yeah, see how they're plugging in every single time. I like solving it first, and then what you're plugging into remains a little simpler. So just another way of going about it. So that's just the first 2 problems. It's just practice checking answers, which we didn't go over in the notes. Then when we make it to number 3, remember 3, 4, 5, 6, 7, we saw those in our previous video talking about interval notation. We saw some number lines. And then once we got to number 8, that's when we had our first solving an inequality. So let's take a look at number 8. It says solve and graph the following inequality. X plus 6 is greater than 3. Okay, so let's get x by itself. Because there's a plus 6, we'll have to, excuse me, subtract 6 on both sides. So then we're left with x is greater than 3 minus 6 is negative 3. So x is greater than negative 3. Okay, now look at this multiple choice option down here. We need to choose the one that has the correct inequality sign. We want the one that has the greater than sign. So you can see there's one of each inequality symbol. Less than or equal to, greater than or equal to, and less than. So in this case, I'm going to choose choice B, and then I'll just type in the number 3. Okay, so it's already in that set notation, the set of all x, such that x is greater than, oh, and it's actually -3. Oops, almost forgot that negative. Okay. Then the next thing I get to do is choose my number line. So which of the following is the graph of the solution set? So if you look carefully, all of these arrows are lined up with -3. So we have to choose based on the direction and the symbol. So greater than is our symbol. So we know we need to go to the right. So that should help us narrow down. So choice A and C over here, we can narrow it down, cross those out. Those are going the wrong direction. They're going to the left. We want our arrow to go to the right. So it's just a matter of, is it the one with parentheses or the one with the square brackets? Because there's no equal sign under my inequality, that means I get to use parentheses. So it's going to be choice B here. The square bracket would be if it was x is greater than or equal to -3. But we didn't have an equal sign. We had none. So the -3 is not included. So that means we're choosing the choice with the parentheses. So it's parentheses, -3, and the arrow's going to the right. We're not being asked for interval notation in this problem, but if we were, the interval answer would be parentheses, -3, comma, infinity, and then close parentheses. That would be our interval notation if we were asked for it. Sometimes you will be. In this case, it looks like we're not. All right, so that was number 8. Okay, number 9, similar problem, but this time it's asking us to type our answer in interval notation. So here's number 9. Y plus 3 is less than 9. So we'll just subtract 3 on both sides. We get y is less than 6. Now watch this. If I type that in, y is less than 6, I'm not going to get my correct answer. Even though y is less than 6, I'm not giving it the answer in the correct notation. Okay, so it's being marked wrong, not because we did anything wrong, but because we're not giving the answer in the correct way. So we need it to be an interval notation. Okay, so how do we do that? Let's see. I'm going to make a little sketch of a number line. So here's 6. Less than 6 would be going to the left. Because we're not including the endpoint, we would need parentheses. So our interval should be parentheses, -infinity, comma 6, close parentheses. So now let's learn how to type that. So we go to our answer blank here. So parentheses, minus sign, and then there's a button we can click for infinity. It's over here in your toolbar. It's the one all the way on the right. It looks like that sideways 8. So I had to type the negative sign first, but then I'm clicking on the infinity. Now, see how I'm hovering my mouse over it? There's a little pop-up. It might be too tiny for you to read, but this is telling me a keyboard shortcut that I can type. There's a backslash and then INF. So I'll just make a note of that, backslash INF. So that's a way you can type the infinity symbol. Watch. So I'm going to type backslash and then I, N, and then as soon as I type the letter F, it's going to magically turn to an infinity symbol, like that. Okay, so you can type it that way, or you can just click infinity. And then comma, 6, and then close parentheses. Another way you can do it is you can click on this thing that says ordered pair, and I can type it that way, negative, infinity, and then 6. Oh, but then I have to get rid of that blue box. Okay. You won't be able to do that for square brackets though, so I'd rather just kind of type it out. All right. Now that I have the interval, I sketched out my number line, which just got cleared. Now I need to choose my number line. So negative infinity to 6, my arrow is going to the left. I have parentheses. So choose the arrow going to the left with parentheses. That's this choice C right here. See the parentheses around the 6, arrow going to the left. Okay, so just pay attention to the directions in terms of, are they asking you for interval notation or not? So here's one where they're not. It's that set notation. So it wouldn't make sense to type in the, parentheses, negative infinity, etc., because that's not the format of this particular problem. Okay, I'm going to skip ahead and maybe we'll find some slightly harder questions. We could probably stand to do some with fractions. Okay, I'm kind of moving along here. Oh, here's one. All right, number 15, it's not fractions, but it's decimals. 0.7x is less than negative 14. Okay, I mean, you can use a calculator at this point, so it's not so bad. 0.7x is less than negative 14. Just divide both sides by 0.7. Going to your calculator will make this easy, or if you look at this fraction here, negative 14 over 0.7, if you just move both of their decimals over one place, it becomes negative 140 over 7, which is going to become negative 20. So x is less than negative 20, but use your calculator, it's fine. Okay, so x is less than negative 20. So let's find our correct choice to type that in. We'll find the choice that has the less than symbol. We'll type negative 20. And then we get to choose our number line. So less than will be going to the left. There's no equal sign, so we're looking for parentheses. Okay, so that's going to be choice B for mine. Going to the left with parentheses. Okay, here's a fraction one. 7/5 x is greater than 7. To cancel out the 7/5, we can just multiply by the reciprocal. So let's just multiply by 5/7 on both sides. 5/7 times 7/5 just cancels out. Meanwhile, on the right side, 7 times 5/7, that also has some canceling because the 7s cancel. We're left with just 5. So x is greater than 5 for that one. Okay, for the sake of time, I'm not going to fill in every single blank here. Okay, here's another one with decimals. This is number 17. Negative 3x is greater than or equal to negative 2.4. So we would divide both sides by negative 3. Negative divided by negative is going to become positive using my calculator. I'm getting 0.8. Now, we're dividing by a negative, so that means our inequality sign will flip. So this greater than or equal to sign is now less than or equal to. So x is less than or equal to 0.8. Okay, so I'll type that in. Okay, ooh, and now I get to also put the answer in interval notation. I was expecting a number line next. Oh, just kidding, I went to the next question. Sorry, number 17, I was all ready to go. Okay, well, it didn't ask for it, never mind. Number 18 is what I was seeing. Now we're back to interval notation. So see how it kind of alternates and switches around what you're being asked to answer. Sometimes it's fill in the blanks, sometimes it's intervals, sometimes number line, sometimes all of them. Number 18 is asking for interval notation. Okay, so this is negative 9 over 2x is greater than or equal to negative 1/4. Okay, so just like last time, we can multiply by the reciprocal of whatever fraction is next to the x. In this case, it's negative 9 over 2. So the reciprocal of that would be negative 2 over 9. Negative times negative will become positive. 2 over 9 times 9 over 2 cancels out to 1. So I'm left with just 1x on the left side. Okay, we're multiplying by a negative. So this is another case where we get to flip the direction of our inequality. So instead of greater than or equal to, now it's less than or equal to. And now let's simplify what's on the right side. Negative 1/4 times negative 2 over 9. Negative times negative is positive. The 2 and the 4 can reduce by 2. So it becomes, let's see, 1 over 2 times 1 over 9 is 1 over 18. So x is less than or equal to 1 over 18. Okay, if you didn't reduce, it would be 2 over 36. And then you could just reduce by 2 at the end. So x is less than or equal to 1/18. Now we need to do this in interval notation. So since it's going in that left-hand direction, this is a negative infinity, comma, and then 1/18. The symbol on the other side of my interval needs to be that square bracket because my inequality sign has that equal sign underneath it. So x is less than or equal to 1/18, but my interval will be like this, parentheses, negative infinity, comma, 1/18. And then I'm using my arrow key. And if you're wondering about square brackets, up on your, if you're using a computer, which you probably are, in your keyboard, look at the top row of letters. After the O and the P, you should see some keys that have these square brackets that you can type. So I'll just do the one on the right. Okay. Good. So here's what it looks like. Parentheses, negative infinity, comma, 1/18. Okay. Looks like we're getting to some longer problems now. Okay, some of these look familiar, similar to what we did in our notes. I see some parentheses we might need to distribute. Okay, let's take a look at number 26. There's multiple layers of parentheses here. So 7 square bracket 3m minus parentheses m plus 6, close parentheses, close brackets, greater than negative 2 parentheses m minus 5. Oh boy, okay, lots of distributing happening here. So we'll work from the inside, inside out. Let's distribute that minus sign into the m plus 6. So treat it like a negative 1. It's now minus m minus 6. And then let's copy down everything else. So 7 square bracket 3m. And then we already have the minus m minus 6. Close up the square bracket. And then greater than, let's just distribute on that other side as well. The negative 2 can be distributed through the parentheses. That becomes negative 2m, and then negative 2 times negative 5 is positive 10. Okay, on the left side, in those square brackets, let's combine like terms. So 3m minus m is now just 2m. So in the square brackets, we have 2m minus 6. We still have that 7 on the outside. Now let's distribute the 7. So on the left side, now that we've distributed the 7, we have 14m minus 42 greater than, and then negative 2m plus 10. Okay, now we can work on getting all the m's on the left side. So let's add 2m to both sides. 14 plus 2 is 16, so 16m minus 42 is greater than 10. Now I can add 42 to both sides. Okay, here's maybe where you're starting to doubt yourself about, wait, is this answer going to work out? I think we're okay. I'm going to erase everything just to clear some space, but we're about to add 42 to both sides. And here's what we'll be left with. 16m is greater than 10 plus 42 is 52. So 16m is greater than 52. All right. Now, if we divide by 16 on both sides, my calculator is giving me a decimal, 3.25. My directions are asking me to use integers or fractions. So that means not decimals. So if this is turning into a decimal on my calculator, let's just instead treat it as a fraction that we can reduce. So let's try to reduce. Maybe we can divide both by 2. That becomes 26 over 8. So m is greater than 26 over 8, and oops, I can reduce some more by 2. So m is greater than 13 over 4. Okay. Now when we type our answer, our directions are asking us to do it in interval notation. So if m is greater than 13/4, here's what my number line would look like. Here's 13/4. The arrow would be going to the right because it's greater than. We would not be including the 13/4. So you'd have parentheses, 13/4. Since we're going to the right, we're going to infinity. So parentheses, 13/4, comma, infinity, and then close parentheses. Okay, that's what interval notation would look like. So let's type that answer. So parentheses, 13/4, comma, infinity, close parentheses. All right, good. So as you can see, by working on these inequalities, you're getting better at your solving equation skills anyway. So this is kind of a good lesson that our unit ends on because it's reviewing a lot of different things that we've covered, combining like terms, distributing, solving equations, all that. Okay, I'm trying to find, oh, that one looks fun. I'm trying to find a harder fraction one near the end. Here we go. Number 31, 2/5 parentheses, 3x minus 1, close parentheses, is greater than 8. Okay, so sometimes we start by distributing a fraction. This is one where we could actually start by multiplying by the reciprocal. Either one would be fine. I'm going to view the example and see what you guys would be seeing. Okay, yeah, it does. It says the first step is to remove parentheses by multiplying. So yes, this one does have distributing happening. Okay, I was just curious what the example was going to show. The reciprocal option would also work. Let's go ahead and distribute though. We'll just make a choice for how to start. Okay, 2/5. Distributing into 3x minus 1. So 2/5 times 3x, if you put the 3 over 1, nothing cancels out. So we're just going to multiply across. 2 times 3x is now 6x, and then 5 times 1 is 5. So 6x over 5 minus 2/5 times 1 is just 2/5. And then greater than 8. So I've distributed the 2/5. Now, let's clear those fractions. So now let's multiply by the common denominator. There's only one denominator of 5, so we'll just multiply both sides by 5. And here, I'll write the 5 next to each term. And that will allow us to cancel the 5s out. So after distributing the 2/5, since the fraction didn't cancel out, now I'm canceling it out. So now I'm clearing the fraction by multiplying both sides by 5. And here's what we're left with, 6x minus 2, because those 5s canceled out. Greater than, on the right side, 8 times 5 is 40. So 6x minus 2 is greater than 40. Now I can add 2 to both sides. 6x is greater than 42. Divide by 6 on both sides. And then x is greater than 7. All right, and this is a fill in the blank question. So I'll just type 7. And that's it. Okay, looks like here's another one where we can distribute a fraction in a similar way. I'll skip over that one. Okay, this is the one I was thinking of. So I think I'll come back to 33 here in a minute. I'm going to take a quick look at 34 and 35. Oh yeah, all right. 34. This is interesting. It's involving decimals, but all my choices involve fractions. That one seems a little hard. And then number 35. Okay, I think 33 and 34 are worth looking at together. You're probably tired by this point in the homework assignment. And the problems are getting a little harder. Okay, here's 33. 1/4, parentheses, 5x minus 1/2, close parentheses, minus 1/3, less than 2/3. Okay, let's start by distributing that 1/4. And then we'll get rid of those parentheses. So 1/4 times 5x is just 5/4 x, or 5x over 4, either way. Because I'm putting the 5 over 1 and just multiplying across. And then 1/4 times 1/2, if I multiply across there, I'm just getting 1/8. Okay, copy everything else down. Still have minus 1/3, and then less than 2/3. All right, let's clear the fractions here. Now we have 3 different denominators, 4, 8, 3, and 3. So 4, 8, and 3 are the numbers we need to think about. 4 goes into 8, so it would be nice if we could multiply by 8, but then we also have this 3. So the common denominator here would actually be, let's see, 8 times 3, 24. So let's multiply every single term by 24. So I'm trying to clear the fractions. The LCD is 24. So I'm multiplying every single term by 24. It's going to be a little messy, but then it'll get better because the fractions will be canceled. Okay, so each one of these fractions should have its denominator canceled out when we multiply by 24. So let's go left to right. Here we go. 24 cancels out with this 4 here, with the 5/4 x. So then 24 divided by 4 is 6. 6 times 5x is now 30x minus. Moving on to the next term of 1/8. 24 times 1/8. If we divide, 24 divided by 8 is 3. 3 times 1 is 3. So far I've written 30x minus 3. Minus. Next term, 24 times 1/3 is going to be 8, because the 24 divided by 3 is 8. 8 times 1 is 8. Less than. Now on the other side, 24 times 2/3. The 24 divided by 3 becomes 8. And then multiplying across, 2 times 8 becomes 16. Phew, so here we are. 30x minus 3 minus 8 is less than 16. Let's keep going. The minus 3 and the minus 8 combine to minus 11. So 30x minus 11 is less than 16. Let's add 11 to both sides. 30x is less than 27. Then if we divide both sides by 30, this is going to be a fraction, I think. So 30x is less than 27. Okay, divide by 30. 27 over 30, we can reduce that by 3. That becomes 9/10. So x is less than 9/10. Okay. Now I'm going to choose my correct multiple choice with the less than symbol. And we got it. Okay, last problem. I know we're doing a lot, but I'm hoping that those of you who are still watching and haven't turned this off by now are maybe getting a little bit out of this. When you make it to these questions on your homework, at least you'll have something to look at. Okay, here we go. 34. 1.3 parentheses 7x plus 4 close parentheses greater than or equal to 1.8 minus parentheses x plus 5. Close parentheses. Okay, all those parentheses we need to distribute. So let's distribute the 1.3. So 1.3 is getting distributed into 7x plus 4. You can use a calculator for that. That's fine. 1.3 times 7 is 9.1. So that's 9.1x plus 1.3 times 4 is 5.2. So 9.1x plus 5.2. All right, then greater than or equal to 1.8. And now we're going to distribute again. This time we're distributing a minus sign, so treat it like a -1. So minus parentheses x plus 5, that's going to become minus x minus 5. All right, so can we simplify here? Let's see, can we combine like terms? Can't really combine anything on the left side, but on the right side, we can combine 1.8 minus 5. So again, using my calculator, 1.8 minus 5, that's -3.2. So let's rewrite the problem. So 9.1x plus 5.2 is greater than or equal to. Because we combine those numbers together, 1.8 minus 5 is -3.2. And then we also have that minus x. Okay. Let's see. I'm jotting this down on my own paper. And then I'm going to take us over to the whiteboard just to have a little more space here, and then we'll come right back. Okay, here we are. Okay, so 9.1x plus 5.2 greater than or equal to negative 3.2 minus x. Okay, now we're getting all the x's on the left side. So let's add x to both sides. Okay, when we're adding x, we're adding 1x. So 9.1 plus 1 is 10.1. So we have 10.1x plus 5.2 is greater than or equal to negative 3.2. Now let's get all the numbers on the right side. So we'll subtract 5.2 on both sides. So let's see, we got 10.1x is greater than or equal to negative 3.2 minus 5.2 is going to be negative 8.4. Okay, so we're almost done. We have 10.1x is greater than or equal to negative 8.4. Okay, let's go on back to the original problem. Okay, so here's where we left off. Let's see, 10.1x greater than or equal to negative 8.4. So I would divide both sides by 10.1. I mean, I'm not expecting that to be anything nice, right? Negative 8.4 divided by 10.1. Yeah, it's a terrible never-ending decimal on my calculator. And now I'm looking at my choices, remembering, oh yeah, I need to write this as a fraction. So let's see. I divided by 10.1. I did not need to flip the sign. So it should be x is greater than or equal to something. So let's narrow it down. It's not choice A. That's the wrong inequality. It's not choice B. Those are both less than or equal to. So let's look at choice C and choice D. Both of them are 84 over 101. One is positive, one is negative. So we know our answer is negative, so that should be enough to narrow it down. Now, where's the 84 coming from? Can you see how those compare? If I just move those decimals over, it's like I'm multiplying by 10 over 10. The 8.4 becomes 84, or negative 84. So, sorry, the negative 8.4 becomes negative 84, and then the 10.1 becomes 101. There it is. So negative 84 over 101 is what's on the right side. So it's x is greater than or equal to negative 84 over 101. Okay. So when you get to these problems on your own, the numbers will be different, but hopefully you've seen enough examples now to at least know how to get started. As always, please stay in touch and ask questions as you have them. And good luck studying, because now you can study. You can go back and review all the sections in this unit, so lessons 9 through 14. Doing the problems in this lesson really covers most of it, honestly. The exceptions would be lessons 12 and 13. Those dealt with formulas, but lesson 9 was distributing and combining like terms. Lessons 10 and 11 was solving equations, which is essentially what we've just been doing. 12 and 13 dealt with evaluating expressions, translating, and solving with formulas. And then, of course, we just did inequalities. Okay, thanks for sticking with me. Keep up the good work, and send me your questions if you have them, and I'll see everybody soon. Thank you.